Guys, this is Malang
and we are students of UMM. How exciting is it to be studying?
What's more?
This is so exciting!
Undergoing a series of processes in this wide campus resembles a commitment to excel. The tagline, "Each achievement is worth appreciation," is reverbing and proven to be real. International robotic contest winners are freed from writing theses. Filming novelists deserves the same scenario. Successful entrepreneurs are offered the same change. More success stories are ready to unveil.
Synchronizing the student achievements, the campus itself hits more lists. Accredited an excellent A from Bank PT. Granted ASEAN Energy Awards triggers UMM to be an energy-generating and saving campus. 13 times in a row awarded as the first-ranked private university in East Java. Central Laboratory guarantees its quality assurance. The quality is evident by being ISO 9001 and ISO 75025. Certified laboratories by National Accreditation Committee. Recognized beyond national scope, most study programs have been internationally certified and accredited by OwnQA, EAB, World Federation Medical Education, and more to go. In 2021, UMM is recognized by Unirank as the world's best Islamic university.
Ucapkan selamat kepada perguruan tinggi Muhammadiyah yang telah berhasil menduduki Top Islamic Universities versi Unirank, yakni Universitas Muhammadiyah Malang pada peringkat 1. Selamat dan sukses kepada perguruan tinggi Muhammadiyah.
I guarantee there are a lot more to come. UMM has shaped its international atmosphere. UMM students are welcomed to opportunities to study with foreign incoming students via HAPS or scholarships, to name regular track, KNB, Dharma Siswa, language and cultural immersion tailored by BIPA. UMM on-campus international corners offer cozy space, American corner, China corner, Thai corner, India corner, and Aussie Banget corner. UMM is renowned for its international community service programs and internship. International collaboration are overflowing. Let's say a collaboration with Temasek Foundation Singapore for community engagement in both countries, Confucius Institute China for lecturer and student exchange, CICIS Australian inviting Australian scholars to dive into Indonesian cultures, and Midcare Japan promoting UMM graduates as a fast ticket to work in Japan. Last but not least, partnership with Erasmus+, European Union Consortium offering international studies, teaching, and research in Europe, and many more. Wow! UMM is wow!
Study processes are enticing. UMM guarantees that the students will graduate in 4 years, be independent, and work.
Is that all?
That's not the end of the list. Character education remains the key. Character and leadership training equips freshmen with strong energy to embark their study. Islamic values are integrated during Quranic literacy program. A tailored course named Al-Islam and Muhammadiyah Studies exemplifies the vision. UMM students are home to care about their make-boring society.
Agriculture, and partnerships. Student practicums are challenging. Students are to seek a real client, and together, they solve their clients' problems. A collaboration with Indana Paint CSR has come up with Jodipan, the village of colors. Rexane goes viral. A lot more to go viral.
We want Assalamualaikum warahmatullahi wabarakatuh. Good morning and best wishes to all of us. The Honorable Vice Rector Academic University of Muhammadiyah Malang, the Honorable Dean of Engineering Faculty, and all the audience. Welcome to opening ceremony International Conference on Technology, Informatics and Engineering 2021. Before we come to the main session, let us start this by Al-Quran recitation.
Assalamualaikum warahmatullahi wabarakatuh. A'udzu billahi minasy syaithanir rajim. Wa idza qila anshuzu fanshuzu yarfa'illahu alladhina amanu minkum Wallahu bima ta'maluna khabir. Shadaqallahul azim. Wassalamualaikum warahmatullahi wabarakatuh.
For the smooth running of the event, we will pray together, guided by Dr. H.M. Nurul Humaidi, MAG.
Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, let's pray to Allah for success, health and happiness. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Wassalatu wassalamu ala asyrafil mursalin wa ala alihi wa sahbihi ajma'in. Allahumma sahhil umurana fid dunya wal akhirah. Allahumma sahhil umurana umuran nadwatil alamiyah fit teknologiyah wal ilam wal handasah birahmatika ya arhamar rahimin. Allahumma sahhil umurana birahmatika ya arhamar rahimin. Allahumma la sahla illa ma ja'altu sahla wa anta taj'alul hazna idza syi'ta sahla. Allahumma barik lana ya rabbal alamin. Allahumma barik lana fi ma razaqtana minal ilmi wat taqwa. Allahumma barik lana fi ma razaqtana minal ilmi wat taqwa bi rahmatika ya arhamar rahimin. Allahumma barik lana fi ma ataitana minal ilmi wat teknologiya bi rahmatika ya arhamar rahimin. Allahumma salimna, Allahumma salim auladana, Allahumma salim jami' ahwalina, Allahumma salim jami'atana, Allahumma salim bi rahmatika ya arhamar rahimin. Allahumma hdina siratal mustaqim, siratal anbiya'i wal mursalin, siratal muttaqin was salihin, bi rahmatika ya arhamar rahimin, bi rahmatika ya arhamar rahimin, bi rahmatika ya arhamar rahimin. Rabbana la tuzigh qulubana ba'da idh hadaytana wa hab lana min ladunka rahmah innaka antal wahhab. Allahumma sahhi ajsadana, Allahumma qdi hajatina bi rahmatika ya arhamar rahimin. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar wa adkhilnal jannata mal abrar ya aziz ya ghaffar ya rabbal alamin. Subhana rabbika rabbil izzati amma yasifun wa salamun al mursalin walhamdulillahi rabbil alamin. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Singing the national anthem Indonesia in Sang Surya. The audience please raise. National anthem Indonesia. Sang Surya.
Two lights
Sip. General Chair's report will be delivered by Dr. Muhammad Abdu MT. Time is yours.
Assalamualaikum warahmatullahi wabarakatuh. The Honorable Professor Dr. Taufik from California Polytechnic State University, USA. Associate Professor Dr. Ing Yasuhiro Mizutani from Osaka University. And Professor Ilyas Masudin, PhD, from University of Muhammadiyah Malang. As the speakers, the Honorable Vice Rector for Academic Affairs, University of Muhammadiyah Malang, Professor Dr. Samsul Arifin, the Honorable Head of LPPI, University of Muhammadiyah Malang, Dr. Fardini Sabila, the Honorable Dean of the Faculty of Engineering, University of Muhammadiyah Malang, Dr. Ahmad Mubin, MT, the Honorable Head and Secretary of the Department at the University of Muhammadiyah Malang, lecturers at the Faculty of Engineering, University of Muhammadiyah Malang, the presenter and participant of ICon-TINE 2021 are happy ones. Bismillahirrahmanirrahim. In the name of Allah, the most beneficent, the most merciful. To all speakers, presenters, and participants, thank you for participating in Welcome to this conference, International Conference on Technology, Informatics, and Engineering, ICon-TINE 2021. ICon-TINE is an annual scientific conference organized by the University of Muhammadiyah Malang. The aim are directed to provide a platform for researchers, scholars, and practitioners to discuss and present their latest findings corresponding to their field of expertise. The primary topics are related to the field of Mechatronics and Robotic, Computational Intelligence, Data Science, Computer Science, Electrical and Control Engineering, Statistics, Physics and Nonlinear System, Instrumentation and Measurement, Mathematical Physics, Biological Physics, Chemical Physics, and Physical Chemistry, Electrical, Magnetic and Optical, Civil Engineering and Industrial Engineering. This international conference theme Technology, Informatics and Engineering is part of the annual International Cluster Conference organized by the University of Muhammadiyah Malang. ICon-TINE 2021 is the first event held by the Faculty of Engineering, University of Muhammadiyah Malang. We have received 107 papers submitted from various sources from Hungary, India, Indonesia, South Korea, Taiwan, United States, and Malaysia. However, only highly quality papers are selected and accepted to be presented in this event. All accepted and presented paper will be proposed to AIB Publishing for publication and will be indexed on leading citation database Scopus. We would like to express our profound gratitude for the Vice Rector of the University of Muhammadiyah Malang, the head of LPBI UMM, the Dean of Faculty of Engineering, the head and secretary of the department within the UMM, University of Muhammadiyah Malang, the lecturer in the Faculty of Engineering, University of Muhammadiyah Malang, all members of the steering committee and the executive committee for their support and assistance during the event preparation. We also really appreciate the participant on the keynote speaker, invite speaker, presenter, participant, reviewers, moderator, institution, especially our partner, Dr. Rabi Rahim, for his involvement and cooperation at the ICon-TINE 2021. We hope this event will strengthen cooperation and networking between researchers, participants, and institutions. Finally, we apologize if there is any inconvenience in this conference due to the committee's limitation. We look forward to the participation of presenter and institution in the next ICon-TINE, which we will be held in May 2022. Good luck and healthy always. Wassalamualaikum warahmatullahi wabarakatuh.
And the next agenda is welcoming speech will be delivered by Vice Rector University of Muhammadiyah Malang, Professor Dr. Samsul Arifin, MSc. Time is yours.
Oke. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Innal hamdalillah la haula wala quwata illa billah. Asyhadu an la ilaha illallah wa asyhadu anna Muhammadan abduhu wa rasuluhu la nabiyya ba'dah. Rabbi shrah li sadri wa yassir li amri wa hlul 'uqdatam min lisani yafqahu qawli, amma ba'du. The Honorable the Dean of the Faculty of Engineering, and the Honorable all of speakers, I would like to mention one by one. Professor Taufik, he is from California Polytechnic State University, and Professor Yasuhiro Mizutani from Osaka University, Japan, and my college from here, Professor Ilyas Masudin. Actually, he has the long degree, but I feel difficult to mention his degree one by one. So I just call him Professor Ilyas Masudin. And the Honorable, the head of the committee, and I also want to mention the director of the Institute for the Scientific Publication Development, Ibu Fardini, and ladies and gentlemen, To be honest, I'm very happy to stand on the stage on behalf of the Chancellor or Rector to deliver an opening remark at the opening of an international conference held by the Faculty of Engineering, University of Muhammadiyah Malang. As far as I know, the Faculty of Engineering has two regular seminars held every year, namely National Seminar and International Conference. I still remember I once opened a national seminar which was held at a beautiful resort in Batu. When it was his first years as Vice Chancellor, it was my first years of my Vice Chancellor at the time, yeah. Then I also delivered an opening remark at international conference held at a 5-star hotel in Malang. A bit to be south, yeah. But I'm sorry, I can't mention the brand because we have our hotel, yeah. I'm so sorry, I can't mention the brand, the hotel. Something that is exciting, at least for me, is that the engineering faculty can take good care on the scientific or academic tradition. The proof is that today, the engineering faculty can hold an international conference for the umpteenth time, that is International Conference on Technology, Informatics, and Engineering, ICon-TINE. Ladies and gentlemen, therefore, on behalf of the rector or on the chancellor and all leaders of the University of Muhammadiyah Malang, I would like to express my highest appreciation to the deans of faculties, the task force team, and the Institute for Scientific Publication Development for their hard work in preparing the implementation of this international conference, even though it was overshadowed by the COVID pandemic-19. The COVID-19 pandemic has forced us to make many adjustments. Of course, if we are asked to choose between online and offline regarding the holding of this conference, then we definitely prefer offline because it has many advantages. However, due to the pandemic situation, the conference was held online. Ladies and gentlemen, I really hope that this conference will become an annual event as one of the markers of scientific development in the engineering faculty. Conference, I think, in my opinion, have many benefits. For us, as a forum for scientific communication to disseminate research results so that we will get many valuable input and criticism for future research activities. Second, the conference will be an entry point for publishing articles in scientific journal, especially journals that have an international reputation. And the last but not least, if we have articles published in reputable international journal, it will facilitate the mobility of lecturers, academic career to reach the highest academic position, namely as a professor. I think all of lecture, including here, want to reach that top position as a professor. One of the requirements that must be met is the availability of article published in reputable international journal. Therefore, once again, I hope this conference can be held every year. I believe we can do it because we have sufficient resources. I think this is my opening remark. Enjoy the conference. Let saying basmalah to opening together this conference. Bismillahirrahmanirrahim. Billahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh. Thank you.
Thank you for the speech, Professor Dr. Syamsul Arifin, MSc, as Vice Rector, Academic University of Muhammadiyah Malang. And now it's time for opening ceremony International Conference on Technology, Informatics and Engineering 2021.
The deal, yeah. I'm meeting the goal will be just 3 times and then the cut. Okay? Bismillahirrahmanirrahim. Dua kali lagi.
Dr. Prof. Samsul and Dr. Ahmad Mubin MT, Dr. Muhammad Abduh MT, thank you for beating the gong as the sign that conference has begun. Give applause. Once again, thank you and please have a seat.
Okay.
And next, we will go to the main event plenary session with keynote speakers. We have 3 keynote speakers. Professor Dr. Taufik from California Polytechnic State University, USA. Associate Professor Dr. Eng Yasino Mizutani from Osaka University, Japan, and Prof. Ilyas Masudim, STM-Log HM PhD from University of Muhammadiyah Malang, Indonesia. And this session will be moderated by Mr. Zul Fatman, MN PhD. But before that, we are excited to share some information about our conference. Please enjoy the video. Yeah, and the next session will be moderated by Mr. Zul Fatman, MN PhD. Good morning, Mr. Zul Fatman. Okay, are you ready for the next session? Okay. Okay, time is yours for Mr. Zul Fatman.
knowledge regarding topic of their presentation. Today, we will have 3 speakers whom coming from 3 different areas of disciplines: electrical engineering, mechanical engineering, and industrial engineering, for around 2.5 hours. The 3 speakers come from the United States, Japan, and Indonesia, respectively. Parallelly, each speaker will have around 30 to 45 minutes to deliver their presentation, and follow with 15 minutes question and answer. Hopefully, audience will prepare their question and comments for the speakers' presentation. The question can be asked directly via Zoom or writing in chat in Zoom chat during the presentation. Let me start with our first speaker today, who would deliver his speech from the USA, in which around 12 hours behind us. I think there right now it's around 8 p.m. So quite far from here. The speaker received his, let me introduce our first speaker. The speakers received his BS in Analytical Engineering in minor in Computer Science from Northern Arizona University, then continue his Master of Science in Electrical Engineering from University of Illinois, Chicago, and received his Doctor of Engineering from Cleveland State University. He joined the Electrical Engineering Department at California Polytechnic State University in 1999, where he is currently a tenured full professor and the director of Electric Power Institute. He received numerous teaching awards, most notably the 2012 Outstanding Teaching Award from the American Society of Engineering Education, Pacific Southwest Section. He is a senior member of IEEE and has industry experience with several companies, including Capstone Microturbine, Rockwell Automation, Picker International, San Diego Gas and Electric, APD Semiconductor, Diodes, Inch, Enerpro, Renewable Power Conversion, and Sempra Energy. His areas of research include power electronics, power system, rural electrification, energy harvesting, renewable energy, and smart grid. He has published over 200 technical papers and journals, reports, books, course readers, and served on editorial review boards of several journals. His specializations in power electronics, power system, energy harvesting, smart grid, renewable energy, and power quality. He will give a speech entitled DC House. This morning, he will give a speech entitled DC House System for Future Homes and Off-Grid Electrical System. Please welcome Professor Dr. Taufik. Time is yours.
All right. A'udzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you, Dr. Zulfatman, for the very nice introduction. I also would like to thank the conference committee for inviting me for this conference. Always, pleasure and honor to be able to share a little bit of what I've done in the field of electrical engineering, especially the thing that I'm passionate about. And today I will be presenting a topic that has been my deep interest since 2010. By no means this is the first time I've presented it. I've presented this topic for so many times and at many institutions. And so the main reason why I would like to bring up this topic again, there are two faults. Very first one, apologize if you've seen this presentation before, and I would like to do this again as a refresher or also as an update, because since the last time I presented this topic in Indonesia, we've done some work on it, and so hopefully this serves as the status update of the project, and that's the very first purpose of it. Secondly, really, I'm hoping that for those of you who have not seen this presentation before, I certainly hope that you'll become interested and join the effort. And you'll see that this topic is not constrained to just electrical engineering. It encompasses other fields of engineering as well, mechanical, civil, what have you, computer science. So that's the second purpose I'm doing this topic, bringing up this presentation again. And by the way, as you all know, my name is Taufik. So even though I am in the United States physically, but I was born and raised in Indonesia. Born in Jakarta, north of Jakarta, and migrated to the US in 1989. So I've been living here for more than half of my life. And so, again, I'm really excited to be here and look forward to interacting with all of you today. Thank you all. And let me start. Hopefully I can share my screen here. Hang on a sec. I'm going to try. And I heard that I have between 30 to 45 minutes. I'm going to try to spend, hopefully the 30 minutes, I'm going to try to respect that and allow more time for Q&A. Can you see my presentation, my PowerPoint?
Yeah, you can see it.
Okay, very good, very good. I'm going to start the presentation. Again, as Dr. Julfatman mentioned earlier, my presentation today is entitled DC House System for Future Homes and Off-Grid Electrical System. And before I go on to this presentation, I know some of you, or maybe majority of you, don't know what Cal Poly is. So I'm just going to do a brief review of Cal Poly. We are a university in the US that was founded in 1901 as a polytechnic college, but then it got converted into a state university in 1972. It is a non-PhD granting school, about 22,000 students, and we are, in terms of the physical size of the campus, we are second largest in California after Berkeley. We have several colleges within our university. We have the Ag and Environmental Sciences, College of Architecture, College of Engineering. They are just like any other universities, and as you can see, College of Engineering constitute the most student bodies in the university. And then in terms of the location, if you look at a US map right here, we are on the west coast of the United States. And if you zoom in to California, this is the state of California. If you zoom in, and here's the long state of California. And then we are located not right next to, but very close to the beach right there, right? And there's the city name is San Luis Obispo. It's a mouthful, but get used to it after you say it for several times. But then what I would like to mention is that our location is strategically placed between two big industrial areas, namely Silicon Valley to the north of us and Los Angeles and Southern California industrial places to the south of us. So in between the two. And it is not too far from the beach, and it is very scenic place for you to visit. So hopefully someday, inshallah, you will be able to visit our place. After this craziness of pandemic is over, you can visit me, and I'll be more than happy to give you a tour. As you can see, this reminds me of Malang as well. That I've been visiting Malang for many times, and you can see this city, San Luis Obispo, is a college town surrounded by mountains, right? Just like Malang. We've had some researchers from different countries visiting our campus, right? From Philippines, from Malaysia, from Indonesia, right? Last year, we're supposed to have 3 more professors from Indonesia visiting us to do a short-term research, but then because of the COVID, it got canceled. But hopefully, someday, if you are interested in doing a short-term research, as well as for students, if you want to do internship, if there's such a sponsorship there from Indonesia, feel free to contact me. Okay. Oh, there's more. Sorry. And then in terms of the ranking, I know you'll be interested always in looking at the ranking. This is the ranking system that the US has internally. So it's not really something that many other countries know about this ranking. So internal ranking of the United States universities is called US News and World Report. And it's divided up into 2 different categories for our non-PhD schools. Cal Poly, out of 1,829, which is a lot of universities in the US, we rank number 8 or 9. 1, 2, 3, 4, 5, 6, 7, 8. And number 8 in the country for engineering. I think that should be enough. If you like to know more about Cal Poly, feel free to contact me afterward. So here's the outline of my presentation today. I have just a few to go over. I'm going to skip most of the line items because of the time constraint. But I'd like to go over why DC, what is DC House project, components of DC House, recent status, off-grid electrical system, future houses as the examples of how we can apply our DC system. So why DC? Right, there are at least 3 reasons, but the main reason back in 2010, for example, early 2010, I realized that the number of DC loads, residential DC load, was growing, right, at a significant pace. As you can see, if I were to ask you, for example, how many of you had cell phones in, let's say, year 2000? Or maybe some of you were not born yet, sorry. How about 2010? Probably not many, right? But then if I ask you how many of you have cell phones today, then I'm pretty sure every single one of you, if not all, right? Majority of you, if not all, will have a smartphone. Right? What is the significance of that? Well, how do you charge a smartphone? How do you charge it? You plug it into the wall, right? And then what is it that you are charging when you plug it into the wall? You're charging the battery inside the smartphone. And what does a battery operate? Is it AC or DC? We all know, right? That's operating on DC. And so that's the reason why I want to bring up that example, because the increase in the number of smartphones represents the increase the number of DC loads in our house, right? Not only that, we also have the increased number of LED light bulbs. The same thing, if I ask you, how many of you have LED light bulbs in 2010? I would guess none. How many of you have LED light bulbs now? I would guess every single one of you, right? Otherwise, you're just wasting energy, right? You gotta have LED light bulbs in your house to save energy. Anyhow, the point is, the number of LED light bulbs increasing as well. And as we know, LEDs running off DC, not AC, right? So that again represents the increased growing number of DC loads in our house, right? Not to mention, other things such as, tablets, laptops, which are all being charged through our wall plug, right? The sockets that you have at home. Now, I just ran this simple number, right? Just to give you an idea, a picture of how significant this number is. For example, here it is projected that by 2021, there would be 2 billion smartphones in the whole world, right? Now think about it, right? 2 billion numbers, 2 billion smartphones. If every smartphone is being charged through USB, which is 5 volts, and let's say every single time you charge it, it'll draw 1 amp. Let's just say that's quite low actually, right? So 1 amp, and then you charge it for 1 hour, and you multiply by 2 billions. You can see that the small power, 5 times 1, which is 5 watts, becomes huge when you multiply it by 2 billions. That's 10 gigawatt hour of energy. So, right? So that's a big number representing the DC loads that would be powered into our house. And then another reason why DC becomes more significant or demanding is that we have this technology that we all know by now called USB Type-C. There's so many interesting features out of USB-C. One of them, as a power engineer, I'm interested in this one feature right there. Is that one of the target spec for the USB-C is that it should be able to provide up to 100 watts right there, 100 watts. Right, so one day, I don't know when, but that is the target that that the USB-C that we all know should be able to provide 100 watts of power. Right, of course, it's going to be at higher voltage, not 5 volts anymore. But 100 watts. Think about 100 watts. Think about how many things can we power, from 100 watts. For example, our laptops, right, can be powered by 60 watts max. So easily, this can handle a laptop. Right, and so the point is, right, imagine if we have more and more USB devices, then potentially we can have more and more DC loads being powered by USB-C. Let's see. Oops. Okay, and then I did some quick survey on the number of percentage of DC loads year 2000 compared to year 2018. This is a typical or average U.S. house. So this is in the U.S. Year 2000, roughly about 20% of the loads in the house in an average home is running DC. Whereas in 2018, that number grows to about 30%. So it's about 10% increase. And my guess is that in developing countries, this number is actually bigger. The DC load is actually bigger. The reason being, because in the US, for example, we like to store food, right? And then we like to have heaters, air conditioning. Those are big AC loads. We like to use washing machines, big washing machines, and those are big AC loads, right? Whereas in developing countries, this may not be the case. So therefore, the percentage of DC loads will be higher, in my opinion, for developing countries. Okay, and then again, why DC? Another reason being that we, as an engineer, we always look for better solution. Right? There's a mismatch between what you're powering and what you are powering and what powers them. Right, so sources don't match the load. Right, you have a source from the wall outlet, from the socket, right? That's AC from PLN, for example, and you are charging a load that is running DC internally. So therefore, you have to inherently convert or transform AC to DC. And in the process, you're going to lose between 17 to 35% loss. Again, if there's only one smartphone, this number may not be significant, but multiply this by 20 billion. Or sorry, not 20 billion, 2 billion, right? That becomes a big loss, right, globally. And so here's just an example to show you how significant this loss is. Again, let's say that you're using a tablet, right? And tablet internally is DC, and then you plug it into the wall, you charge it, right? And in the process, let's say you lost 5%, let's just say, which is a small number, right? I'm sure it's going to be bigger than this. But then we know from statistics that by year 2016, for example, there were 760 million tablets in the world, and every single tablet consumes 12 kilowatt hour per year. and go ahead and multiply that by 5%. That gives you 480 gigawatt hour per year. Is that a small number or a big number? I would argue that's a big number, right? That's just from tablet. What about from a smartphone? Smartphone, 2.751 billion per 2019. It consumes around, on average, 4.2 kilowatt hour per year. Go ahead and multiply that by 5%. You get 599 gigawatt hour per year. Is that a small number? Heck no, right? These are big numbers. So if you add the two, right, the number that you get out of after you add the two represents the same number of, not the same number, it represents 12 units of 10 megawatt power plants that's operating 24/7 for the entire year. What do you think of that? Right, that's pretty significant, isn't it? Right. So these loss that we get from these two devices, right, can if we are able to save this energy, we're able to prevent, right, save money by not building power plants, right? So that's how significant it is. Another reason why DC is that we are witnessing the increased use of renewables, especially PV, right? And PV by itself, it's inherently DC, so that represents, sources that are DC. That's becoming more prevalent, right? And if the source is DC, such as from PV, our load is DC, then I would argue that the most efficient way is to convert from DC to DC straight without having to do this, because this is what we are having now. Right? If you have a rooftop solar panels, you have to convert that DC from PV, from solar panels, to AC. That's going to give you 23 to 28% loss. Then once you transform it into AC, then you have to convert it back into DC, which gives you about 17 to 35%. And because the DC level doesn't match the load, then you have to also add DC to DC converter. That's going to give you about maybe 5% more loss. So you can see by having multiple stages like this, it's not really efficient, right? So that's another reason why you want to look for a DC solution. And another main reason is for DC is that we want to provide opportunities to help our brothers and sisters around the globe, not just in Indonesia, to be able to enjoy electricity, right? To be able to take advantage of electricity, right? And for people living in the rural areas, they do have plenty of renewable energy sources, but unfortunately, the technology, doesn't quite accommodate, them for using these plentiful resources. So that's too bad, right? And so we want to help them. And as you can see, this is a picture of Indonesia, or not just Indonesia, but at night you can see most of the Indonesian islands are still dark. Right? So that's proof to us that there are still a lot of our brothers and sisters living in the islands of Indonesia, are still not taking advantage of electricity. We want to help them. And I grew up without having electricity. I remember growing up, I had to use a kerosene lamp. I know some of you probably have had the same experience. And we remember how inconvenient, right, life was without electricity, right? And this is dangerous as well. Health risk, right? So even if by doing this, even if I can put one smile on on these kids, for example, that would fulfill my dream as an electrical engineer, right? Okay, so those are the reasons why DC. Now, DC House is an idea that I started in 2010. The idea here is to develop a residential DC electrical system. The initial goal is to develop an alternative solution to existing rural electrification technologies by using direct use of DC electricity with DC loads, while having seamless integration of one or more small-scale, so here's the key words, right? Small-scale renewable energy sources, right? And I'm not taking credit on the DC system itself, because that was invented a long time ago, right? Edison versus Tesla, you probably hear that, you heard that battle before. But what I'm trying to do is I'm trying to expand previous ideas with a more comprehensive approach, scalable, reliable, and utilizing multiple small, not just one big renewable energy, but multiple small scale. And it's a bottom-up approach because we want to be able to provide a low-cost solution, not just a good solution, not just a fancy solution, right? But also not just an efficient solution, I should say, but also a low-cost solution, right? Something that people in rural areas can afford. Right? So bottom-up approach instead of a top-down approach to rural electrification. And I understand that one size doesn't fit all. So existing solutions may not be suitable for many rural remote areas, such as I know that UMM has this micro hydro power plant, and I'm not against that. Don't get me wrong. I'm fully supportive of all of these efforts, but we also need to realize that micro hydro does not answer all challenges, right? It is suitable for some conditions, but they may not be suitable for other conditions. Right? So one size doesn't fit all when it comes to rural electrification. So we need alternative solutions, not just one solution. We need as many solutions as we could offer. Right? That way we can reach out to every single one, person in the world that still does not, take advantage of electricity. And we need to have a small scale, more adaptive solution rather than centralized or big scale solution. And these are all the features that I'm aiming at for DC house. I won't go through this, but these are the features, okay? Reliable, scalable, multiple, expandable, reachable, and flexible. And here's the diagram of the DC house project. Some of you have seen this before. There are three different aspects of it. You have the generation aspect of the DC house. So these are all small scale. Okay, these are not big scale. These are all small scale. So tens of watts, even singles of watts could help. The key here is to be able to combine all of the energy into one, right? Into one single bus. And here's the DC house right there, means that the house runs purely on DC, right? And then you have the generation, small sources, and then you combine the energy, right? By this combiner called MISO. Our keynotes, one of the keynote speakers from Japan, I believe, right? And so we know MISO soup, right? And but our MISO is not a soup. Our MISO is multiple input, single output, right? Converter. So that's what MISO is: multiple input, single output. Multiple inputs from small scale renewable energy sources to single output to a DC bus, and that feeds into our load. So that's three aspects: generation, interface, and load. So all these three aspects is something that you could develop. As I said in the beginning of or the prelude of this presentation, is that this project is not constrained for electrical engineers. Mechanical, civil, what have you. It can also contribute to this project. This is just some examples on the source side. Right, you could have this idea of having portable nanohydro. Back in 2011, I had this idea, but I keep failing because I am not a mechanical engineer. So I tried, and I couldn't get it to work. But then somebody in Europe actually came up with the same idea and got it to work. Right. Basically, the idea here is that you have a small scale hydro power, right, that you can carry in the pocket, and you put it in a small water stream. Just unlike micro hydro, right? Micro hydro, you need big river. Here, you only need a water stream. Any water stream, you just dip this generator into the water stream, and it'll generate power for you. It's not big, but here's 25 watts, but that's enough. If you combine with other sources, that will be enough to power our DC house. And rewinding alternator, a car alternator, right? Because that's a high speed. You want to convert it into low speed so you can do something like this, right? Because we want to have a low-cost solution. Play park generator, right? At Cal Poly, we've developed different play park generators in a swing, so kids can play in the swing. At the same time, they can generate power to the house. And then we also have, seesaw, and then we have the merry-go-round. They can also generate power while they are playing, while the kids are playing with them, right? And then on, going to the control aspect of the DC house, you have this source manager. So you can have centralized energy management control. This is another study that you can do for DC house. You need to be able to monitor and control 3 different aspects of the DC house: the source, the interface, and the loads, right? And put all the information into the central controller so you can decide from where the power should be coming from. Should we charge or discharge the battery, and so on and so forth. And don't forget that it could also be the HMI aspect of it, human machine interface of this, right? Or you can also build an apps to make it easier for us to interact with the system, right? And on the MISO part of it, yeah, it's easier, said than done. The idea came around 2010, and then we tried, we came up with different solutions until 2019, alhamdulillah, we finally found the solution. We received a US patent. There's our circuit that does the multiple input, single output, right? That can combine those energy sources. On the load side, there's so many things you can develop, right? I'm just going to mention a couple. For example, smart wall plug. This is an interesting area because especially, intelligent controls, for example, right? The problem with DC is that it's not standardized, right? In AC, everything is standardized, right? In the house, you would have to have 220 volt AC, for example. All the appliances, all the things that you buy for AC is 220 volts. But DC, there is no standard, right? So it will not be wise if you have multiple wall plugs, right? Imagine in your house, if you are running DC, you don't want to have multiple wall plugs. One that goes for 5 volt, another one for 12 volts, another one for 24 volts. That's silly, right? Because not everybody understands, electricity, right? So the most or the more practical way is to have a smart wall plug, where the wall plug can actually determine the voltage level the load is asking. So if you have a wall plug, DC wall plug, you plug in any DC load, that wall plug is able to search to determine output, right, the right voltage. And then we also have this DC circuit protection. DC is known to be more difficult to protect because it's always high, unlike AC. AC goes up and down, up and down. DC is always flat. So it is more difficult to protect. And we came up with this circuit that protects our DC circuit from arcing, right? So arcing, to interrupt arcing, I should say, right? Monitoring and detecting arcing in DC is actually more difficult than AC. So we found a way to actually do that several years ago. And here's just a picture of this smart wall plug. Imagine you have a wall plug, you plug in a DC load, and the brain behind the wall plug is able to output any DC level the load is requiring. Okay. And more opportunities, I guess, right? In Indonesia, for example, we have villages with cluster homes like this, right? So if you have this, then you might want to have a network of DC house, such as this, right? So then you're faced with the challenge of exchanging energy, right, from one house to another house. If every single one is a DC house, then you might want to be able to exchange the energy. So here's an example, quick example of the advantage of using localized energy, localized source, or localized or decentralized rural electrification system compared to centralized, right? So this is our conventional system on the left. The one on the right is what I'm proposing with a DC house. So on the left, let's say you have a micro hydro or whatever it is, a solar farm, right? Centralized, any big centralized source, and you got to have the power station. You might have the battery, and then you power from that one source, big source. You power these different houses with distribution system. Let's say 3 lines like this, right? And here's the system with DC house. So every single one of these houses is DC house with its own solar panel. It could also be other things. It doesn't have to be solar panel. And it can produce, or it can you can provide or consumes energy, just like that. So bidirectional, whereas this one is unidirectional. Right? So you can see that if you have a conventional system, let's say the source, the micro turbine, or not micro turbine, the turbine broke, for example, then every single house will be black, or will be dark, I should say, right? Will be dark, right? Or black out. If the power station breaks, then again all these houses will black out. Right? If that one single line from the power station breaks, all the houses are down. If that line right now breaks, then the top houses will be down. Right? If that one single line from the top line into that house breaks, then that one house will black out. Right? That's what you have with our current system. If you change it to a DC house system, as an example, it doesn't have to be DC house, but any distributed system with its own source, let's say that the source or the solar panel on that house breaks. Would that house be blacking out? Well, not necessarily, right? Because that house could be supplied by the neighbors. So it could still be light on that house. If, for example, that line is off right there, is broken, then since the house has its own source, then that house is still okay, still not blacking out, right? If that line breaks right there, what do you think, right? I think every single house would still be okay. No blacking out there, right? And so on and so forth, right? So hopefully that brief example will give you an idea of the advantage of distributed generation. Opportunities, just briefly on the small scale energy source, you can see we have, small scale type of sources, right? From solar tree, this has been done before, of course. And then we have these wind generators, small ones that looks like a leaf, right? But it's actually generating power. And these are all localized, small scale that we can definitely use for DC house. So, sky is the limit when it comes to creativity. So you can definitely come up with different ideas on this. How about everything's DC appliance, right? For those of you who are interested in coming up with a creative solution for DC appliances, again, sky is the limit. You can have DC air conditioner, which has been done. DC freezer has been done. And USB-C powered appliances, this has not been done before. So this is a big things to explore, right? USB-C powered appliances. Remember, USB-C can eventually be able to power 100 watts of a device, right? So imagine that. And then on campus, right, you can have solar panels, and then you can have purely DC circuits instead of converting it to AC and then back to DC. Why not just straight from DC to DC, right? You can have a DC wall plug connected, right? Instead of inverter and then DC to DC converter. Solar roof tile, again, not a new idea, but something that definitely you can develop to support this. And here's my what I envision to be in the future. I envision that in the future, a house, urban house, doesn't have to be a rural house, will be a hybrid type of house. A hybrid type of house would be that a house that runs with two electrical systems, AC system, let's say from utility or PLN, and your own source, let's say solar panels. And the utility will run the big AC loads, whereas the solar panels will run straight into the DC load, such as lightings, USB type of devices, and you can crisscross between the two. You can see that the AC, you can go into DC, right? See the AC goes to DC to power DC load, just in case the rooftop solar panel is down. All of these DC loads can still be powered by the PLN. Likewise, if let's say PLN is down, right, the AC loads could be powered by the rooftop solar panels, assuming there's enough energy. You can cross from DC to AC that way, right? So with the hope that we're going to use less and less power from the utilities, right? That's the idea behind net zero energy building. And so DC House provides the foundation for net zero energy building as well as smart homes that use sensors. As you know, sensors, these are all powered by DC. So if your house runs on DC, then it will be seamless, right, to integrate sensors. I'm going to skip on this one. And these are just showing you the different prototypes that we've had so far for DC House. We have one at Cal Poly, one at Pajajaran University, and one in the Philippines, Technological Institute of Philippines, and also in the Regency office in Jatinangor. And it is a huge undertaking. That's the reason why I would like to bring up this topic, because I'm hoping that some of you will be interested in joining this effort, right? I'm just these two hands, right? I need more hands to help me. I need more ideas from you to be able to achieve the goals of the DC House project. So as a summary, residential DC loads will become increasingly prevalent in types and capacity, coupled with increasing use of PVs, the need for developing residential DC electrical system to facilitate the efficient use of DC sources and loads becomes crucial. And residential DC electrical system offers an alternate solution to rural electrification. So by no means I'm trying to replace the existing solutions, okay? I'm just offering an alternative solution. And there's still a lot to explore, develop, crossing various disciplines. But on the software side, in case you're interested on the software side, we need help on energy management system for monitoring and control sources and loads, energy management system for power exchange in the DC House network, and also in the smart DC wall plug. And so with that, I know I'm kind of go through this real fast, but hopefully it should provide you with enough information and background on the DC House project. And that will be the last slide for me. If you're interested in finding out more about DC House, I do have the website, dchouse.calpoly.edu, and or feel free to email me at taufik@calpoly.edu if you are interested in knowing more about the project. And with that, I'm going to stop sharing. Thank you. I hope that you learned something from that presentation. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Prof. Taufik, for very nice presentation. Prof. Taufik already delivered about a DC house from the idea until what he was developed. And then also some hopes for the audience who coming here to also develop DC to DC technology, especially who come from mechanical or electrical engineering, who concerned with this issue. Okay, we still has around 13 minutes to Q&A. We have already 2 questions. The first one from Mr. Daryono. The question is the need on DC power would be become increased from time to time? And the second one from Mr. Muhammad Nasser, what and how we have to do to deal with the industries that continues in producing AC equipments? I think most of us ask the same thing, how the idea can deliver to the government, universities, or industries to follow this idea, and then make sure that the DC technology, DC to DC technology, become the next or future technology for our electricity. Please, Prof. Taufik, time is yours.
Yes, thank you. Would need for DC power increase from years to years? The answer, this is just my personal opinion, based on the statistics, of course, right? Based on the numbers that we've seen, in terms of the number of the DC loads that we have in our house, the answer is yes. right? I think the main driving technology for this is power electronics. A reason why people would like to use DC more and more and more, because now we have a way to efficiently convert from one form of energy to another form of energy through power electronics technology. This is the tool that Edison didn't have a long time ago when he had a war with Tesla, right? Remember AC versus DC, and eventually AC won the battle because at the time I think Edison had the right idea with the DC system, because that's what we're doing now with microgrid, right? Microgrid is nothing other than localized, distributed generation. That's Edison ideas, right? But then, unfortunately, Edison back then didn't have the tool, didn't have the technology to achieve his, his system. So he got beat. And so I think based on the advancement in technology, mainly power electronics, semiconductor, sensors, we will have more and more DC in the future in our house. Right? Transmission, electrical system like a PLN type of electricity, that would still be AC because it's too late to change to DC. Right? It's expensive to replace infrastructure from AC to DC. What we can do here is to improve, right, the system on the customer side, on the user side. Right? So rather than using more and more AC, now we can transform everything into DC once the electricity comes to our house. So the answer is yes, in my opinion. And then what and how do we do to deal with the industries that continue to produce AC equipment? Yeah, unfortunately, this is industries will be driven by technology as well, right? But luckily, we've been seeing that the trend is pretty much going to DC, right? The trend is pretty much going to DC with all this battery technology, sensing technology, IoTs, and all of these, right? These are all DCs, right? LEDs, these are all DCs. So it will be tough for just academia to try to convince the government to change, but it'll be easier if the industry helps. And luckily, the industry does, in this case, confirm that DC is basically more. It can provide more advantages, on the user side than AC. And so, how and what do we do? Well, hopefully by having this presentation, more and more of you will be participating in this effort on the academic side. Of course, on the academia side, you do more research on DC, and then on the same time, the industry are doing their own things to do DC as well. So together, without trying to convince the government, the industry, they would just follow the trend, right? They would be playing along with the trend, and I'm pretty sure that someday we'll have more and more DC, right? Take a look at solar panels. More and more people are using solar panels, right? And more people have become aware of the fact that solar panels are outputting DC. It becomes, it's making no sense at all for you to change from DC to AC and then back to DC, right? You're just wasting, your energy that's already hard to achieve from solar panels. So anyhow, so convincing the government, I think that will be the least of what we need to worry about. I think the industry would speak to themselves, right, of this potential of DC. Yeah.
Okay, thank you, Prof. Taufik, for the answer. We open two more questions for the audience. Maybe maybe a direct question from Zoom. Just raise your hand. Does anyone? We are waiting for two questions. Okay. No more question. Okay. In terms of how are we driving the policy from the government, Prof? How you already state how we have to do from academician, or because it's related with the question from Mr. Nasser. Industries still continues to in producing AC equipment, and then most of AC source, electrical source is still AC. And how we can convince government to make a new policy about this? For example, maybe 2030, for example, in Davos, for example, President of the United States said that we move to DC. All our electricity we move to DC, but most of our sources still AC. What about this, Prof?
Yeah. So I think the answer to that is that AC will not go away, and as I said earlier, when it comes to transmission and distributing power, it will still be AC. So all the transmission systems that you'll see will mainly be AC. There will be some DC transmission, but I think AC will still be the most dominant player. So the convincing part should not be on the source side. It should be on the user side, right? And I don't think we need any effort to convince the government, because we are the one who's using the electricity, right? And then the government will understand that. Although I would say they would inherently, see the trend. For example, LEDs, right? LEDs is purely DC, right? We don't need to convince the government, hey, let's change the lights to LEDs. Without doing that, every single one of us is replacing our light bulb with LEDs. Am I right? At least that's what I'm doing here in the US. I don't need to convince the government to switch everything to DC. We are the one who's using electricity, right? And as I said, the only thing that we can do these days is to change our mindset, right? About DC, right? Spread the knowledge about awareness about DC, and so by doing that, hopefully we are able to educate some of the politicians or policymakers that when it comes to using energy from our restricted sources, it will probably be better to use DC at our homes, right? By again showing them the different products, right? That we have in DC, right? And so yeah, like I said, I don't think we need to be to convince the government. I think the technology will speak to themselves, right? Yeah, that will be my opinion. I mean, batteries, the same thing, right? Batteries running off DC. The more batteries being used, the more we know that DC becomes more dominant, right? Without trying to convince the government. Yeah. And again, I'm hoping that the industry will be the driving factor of this, right? Yeah, I don't know if you know, there is already a group of companies who already setting up standards for DC. It's called DC Alliance, and these are all big companies, global companies who are looking at DC, who are looking at coming up with the standards for DC, right? And they're the one who's going to be convinced, who's going to be the biggest player in convincing the government. Right. Trust me, I've tried to convince many people in the government about DC House. That's not an easy thing to do, right? I think the more we use DC, the more we can convince the government to change the policy, or to at least put a policy in place for DC. Yeah.
Okay. I think time is up. I think it's enough for this section. Thank you very much, Prof. Taufik. Let's give a big applause for him.
Thank you.
Thank you very much, Prof. we will continue for the second presenter. Our second presenter is Associate Professor Dr. Yasuhiro Mizutani. He is already here. Let me introduce him. Yasuhiro Mizutani received the BE and ME degrees in nuclear engineering from Osaka University, Osaka, Japan, in 97 and 99 respectively. He obtained the PhD degree in mechanical engineering from the Tokyo University of Agriculture and Technology, Tokyo, Japan, in 2008. From 1999 to 2003, he worked as a researcher with Panasonic Corporation. Then from 2003 to 2009, he worked as a research associate with the Department of Mechanical System Engineering, Tokyo University of Agriculture and Technology. In 2009, he joined the University of Tokushima as an associate professor. Since 2015, he has been working as an associate professor with Osaka University. He is also with GST, Ioreto, Minoshima Intelligent Optical Synthesizer Project, Fukushima, Japan. He has author or co-author over 100 papers in referred international journal and conferences in areas of his research interests. His research interests include interferometry, polarimetry, 3D surface measurement, optical trapping, and 3D lithography. He is member of International Society of Optical Engineering and the Optical Society of America. His specialization is in nanotechnology materials, manufacturing technology, informatics, mechanics and mechatronics, robotics and intelligence system, manufacturing technology, manufacturing and production engineering. This morning, Professor Yasuhiro Mizutani will deliver a speech entitled High Speed and High Resolution Ghost Imaging with Deep Learning. Okay, I think the time is around 30 to 45 minute presentation, and then we'll continue with question and answer. Time is yours, Professor Yasuhiro Mizutani.
Terima kasih. Thank you very much for your very kind introduction. Good morning. My name is Yasuhiro Mizutani from Osaka University. Thank you very much for inviting me, and I'm very honored to be here. First of all, I will share my presentation. Okay. Can you see this slide? Okay.
Okay, Prof. I can see it.
Okay. Thank you very much. Today, I'd like to talk about my research work, which provide you a very simple new imaging system with deep learning. This is a very simple system, so you can make this instrument. First of all, 2 years ago, I have visited Indonesia for first time. That is a very nice. Indonesia is a very nice country. Very nice country. and this is, I like Indonesian culture and dancing, and Indonesian people is a very nice student, and also Indonesian food is very nice. These taste like we like all. I think all Japanese people like the Indonesian taste, and also I like durian, like this. I like very much, but in Japan there are no durian, so I want to eat the durian. So after pandemic, I will go to the Indonesia. Thank you. And this is outline of my presentation. First of all, I will introduce our university, and then I will explain about the ghost imaging, which is a new imaging technique. And then by using these techniques, I provide the applications, especially for the weak light detection. And then by using or combining the deep learning method, we construct the high-speed or hyper-resolution imaging technique. And finally, I will conclude my talk. As you know, Osaka University, Osaka is located on the middle west side of Japan here, and Tokyo is here now. In the Tokyo has hosting the Olympic Games. So in Indonesia, badminton is very strong here. So so Osaka University is located on the north part of the Osaka here, and we have 3 main campus, and my research laboratory is located on the Suita campus, like this. This is a very large campus. And this is a brief history of the Osaka University. Our roots is about the 19th century, which is a medical school. And then we have founded the early 20th century. Osaka University is going to the Imperial University, funded with the support from the business government of the people, Osaka people. And now next 2031, the 100th anniversary since from the founded of Osaka Imperial University here, this one. And here is a student number. We have undergraduate students, about 15,000 students, and master, doctoral, academic staff is here. There are many people in our university. Osaka University is one of the Japan's leading national university. And here is graduate or we have 16 graduate schools and 11 undergraduate schools here, and there are many departments. But engineering or science is a main department in Osaka University. Also, we have many research institutes or faculties, and we have 6 research institutes and 16 center of facilities. So almost research institutes located on the Suita campus area. And also, we have many collaboration with Japanese company like this. There are this is a joint research laboratory. So this is a very big foundation from these companies. And this is engineering department faculties. We have 4 main faculties. This is applied science, consists of biotechnology or chemistry, and mechanical and material and manufacturing science. And I am a member of mechanical engineering here, and also electrical and information technologies, and sustainable engineering or global architecture engineering. So this is a department of mechanical engineering. There are many kinds of the mechanical engineering. As you know, mechanical engineering consists of many fields. So my research field is nano measurement in production. So very precisely measurement development. And also, we have many international students from all over the world, especially Asian is 80%, and about 2,500 international students. And from Indonesia, there are many students. Therefore, if you want to join our university, please contact me. So I prepare you are joining. Well, this is our research laboratory opportunity. We have developed the core technology for challenging to create a new methodology. By using this new methodology, we overcome these problems such as environmental crisis, food crisis, or human originated disasters. So this is we have 4 main themes. One is a laser applied nano measurement and evaluation. And second is a laser applied nano fabrication, which consists of about 3D lithography. And third is a novel nano production technology for the production machining. And finally, next generation methodology based on the quantum optics. So by using this core technology, we want to overcome, we will overcome these problems. So in the mechanical engineering, there's a social background and there are some problems in the worldwide wave. As you know, there are IoT or the Industry 4.0. The network come to connect the factory all over the world. But in this situation, there are some problems about the traceability in each factories, and the national standard is very important. Also, in the one factory, here is a physical real world, and there are many belt conveyors and many robots, and there are many production, but the optimization or sensor, all devices, it is very difficult, and there are many spent of the time. So to overcome the problem in the machine production system, you can make a cyberspace in same situation. So this is named as a digital twin system. So by optimization in the cyberspace and the parameters is feedback in the physical space. So this is a very useful. But in this area has many sensors. So especially 2D sensor is there are many 2D sensors, but 2D sensor has many information. So one problem is traffic volume. So to overcome this problem, we focused on the only one pixel imaging here. This is naming a ghost imaging. As you know, 2D sensor, or maybe you have a smartphone camera. The camera has a megapixel imaging. So, but this is a very nice, beautiful. You can take image, but traffic volume is very huge. So we provide the only one pixel imaging instead of the megapixel image. If you can use this single pixel image, as you know, you can make a downsizing system. So it is useful for the Industry 4.0. This is architecture of the ghost imaging by using computational information. So this is a sample for imaging, and this is an illumination pattern, and the light scattered or transmitted light is detected by the single pixel like this picture. So by only this information and these information by using a 2D imaging imaging. This is a very simple setup because the imaging lens is very complex. So this is that is a very problem for making instrument. But this is only one pixel that is easy to construction. Here is an example of the single pixel imaging system. This is a very basic setup. The single pixel detector is set on here and the sample here, and this is an illumination system such as a projector, DMD projector. Very simple. By using this, therefore, you can make the existing. You can make. You can set on the existing instrument like this picture, DMD projector here, like here, and the sample is here, and the detector, single pixel detector is here. This is easy to set up. Also, you can make a very little bit complex microscope like this picture. So I will introduce the principle of why you can image by using the only single pixel, because this imaging is based on the second declaration of a function. Here is a covariance. Delta V means the intensity fluctuation of the signal detected by the single pixel detector. And here delta I, X, Y is illumination distribution of the illumination pattern here. By correlating these two signals, you can detect the correlation function as an image. So this is a principle of the ghost image. This is a schematic illustration of the imaging system. Here is a sample, and you have to prepare the random pattern illumination by using a DMD, and the pattern is controlled by the PC personal computer. So the pattern is irradiated on the sample, and then on the sample there is a scattering or transmitting reflection or the fluorescence light. The light is detected by the single pixel detector. By using a single pixel detector, which depends on the illumination pattern. So by correlating these two signals, you can detect the sample image like this picture. And here is one of the example of the system. As I have mentioned, the system consists of the DMD projector and sample and single pixel detector. And this is an example of the imaging for this sample. This is a standard resolution target. This is a region of inspection, a region of image, and this is the imaging system. As you can see some math characters and some patterns. It is easy to construct. And this is one of the very advantage of the ghost imaging. This is a sample of the pinhole imaging, and then the irradiation light is decreasing, very decreasing here. And as you can see, this is a signal for detecting the photodiode. And 20 milliwatt is a nice high signal to noise ratio, but this laser power is, I think you cannot see where is the laser on, but the imaging result is here. And as you can see, the quality of image is almost same between these two images. So this is weak light imaging is advantage of the ghost image. And this is a experimental result by comparing the normal imaging system. This is a scanning type imaging. This is a very standard imaging system. So here is a sample, and if the laser power is, in the case of the higher, using the higher intensity, the detected image is clear by using a conventional normal imaging system. And also, ghost imaging can be realized to detect the high quality imaging. But in the case of decreasing the signal to noise ratio, by using a scanning image, you cannot see the sample image. But by using a ghost imaging, you can see the sample hole here. So this is advantage of the ghost imaging. And this weak light advantage is applied to biology imaging. This is a background of the biological imaging, one of the problem. Here is a fluorescence imaging detecting by the normal fluorescence microscopy. As you can see, here is a same cell, but this is detection time. Here is 2 hours and 18 minutes. The fluorescence signal is decreasing, especially like these pictures. There is no signals in 60 seconds. This is a phototoxicity or the photo bleaching problem. This is one of the problem of the biological imaging. So this problem derived to the intensity, high intensity of the light. So by using a decreasing the light intensity at irradiated intensity, so the photon number is very decreasing, like these pictures. So very is lower intensity. So by using these signals, you can detect the biological samples. This is one of the example of the photon number dependency, imaging quality dependent on the photon numbers. In the case of 100 photons, very low intensity, you can see this is signals. And in the case of decreasing the photon numbers, the quality is also decreasing, but you can see the sample positions. About 20 photons, you can see, maybe you can see the number, you can see the sample position. So applied to the biological imaging, one-day fluorescence imaging here. This is this sample is a human breast cancer cell like this, detecting by the normal fluorescence microscopic image. This is a very nice quality, but by using this light intensity in the very short time, there is a photo bleaching, and then you cannot see the sample. So by using very lower intensities, but you cannot, by using a normal microscope, you cannot see the cell image here. But by using the ghost imaging, you can see the cell cell position here, and also one-day imaging, the quality of image is almost same. This is an advantage of the ghost imaging. Here is a short summary of the ghost imaging. By using a ghost imaging, you can develop the downsizing imaging system, and faster detection. You can also make a faster detection system because this single pixel detector has a high frequency response. And also you can make a high flexibility. You can make an optical setup for with high flexibility for wavelengths. Especially there is X-ray or gamma ray. There is many single pixel detection. So you can easy to applying for other wavelengths. Also, I have introduced that there is a high sensitivity by using ghost imaging. But the ghost imaging has one of the very key point problem. But as I have mentioned, the detection imaging method you have to correlation these two signals. This correlation signal is this is one of the experiment result. The one 10,000 measurements. That is a very problem because you have to spend so many times. If in the case of decreasing this measurement, you can not lower quality measurement. This is a very problem. So to overcome this problem, we focused on the neural network here. As in this case, this is a ghost imaging with low quality ghost imaging, but high speed. However, you cannot see the image of the sample. So to compensate, to overcome this problem, we combined the convolutional neural network. So by using this network, you can detect the high quality image. As you know, this is a neural network. Normal neural network, as you know, image recognitions, we applied the by using a image recognition technique to the ghost imaging. As you know, the input image in the case of image recognition, the input image is indicated the output probability. In this case, is the probability of the car is highest in other cases. So applied this technique, we derived the probability of the light existence at all pixels, okay? And then reordered this probability so you can detecting the image. This is a probability mapping. But to construct this network, we analyze the low quality. Why the ghost image is low quality? Here is there is an error in the ghost imaging. There is two main reasons. One is a local reason and the global reason. And one is alternative hypothesis intensity frequency. So there is this distribution in the area for this example 1011 means but this area is 1111 and they are not equal. So this is one problem. And other problem is here, a broad image pattern. As I have mentioned the illumination pattern is irradiated by using a DMD projector. The DMD projector has some lenses, and so the pattern is broad by using a point spread function and convoluted. Here is a real pattern, projected pattern on the sample. This is not these two are not the same. Here is a local problem. And other problem is here, and there are many noises in environmental area, such as atmospheric turbulence, or stray light, or the shot noise, thermal noise, or dark current. This is a global noise. So to overcome these problems, we combine the convolution and dense layers. So by using these layers, we have developed the ghost imaging system with a deep learning. This is a numerical numerical simulation-based analysis. And here is a sample, setting a sample, and we set only 1 pixel here, and detect image size 28 by 28, very low imaging size, but very basic system. So measurement number is 5, very low measurement number. By using these numbers, ghost image is here. There are not same. I think you cannot see where is the sample here, but by using with deep learning, and this number is iteration number. As you know, there are many parameters in the neural network, and optimizing by using iteration. Iteration is 100 iteration, and you cannot see, I think here is small signals, but by using a 2000 iteration, you can see the very simple, clear image. So this is one good for the ghost imaging. This is a quantitative comparison of the ghost imaging. Here is this axis means the measurement number. Here is the quality of image. CNR means the quality of image. And this solid line means ghost image or normal ghost imaging. And in the case of ghost image with 5 measurement is here very low quality. But by using the deep learning with 200 iterations, the quality is very high. And this means this quality is here. And and this is same as normal ghost image with 300 measurement. So by using our provided technique, you can make more 60 faster than the normal ghost image. This is a very advantage. So by using this instrument, so we detected the transparency sample, and here is a DMD projector. The light is irradiated onto the sample here via the objective lens, and then the scattered light detected by this photodiode. This is a very system. Here is a experimental result. And this is a glass microsphere. As you know, glass microsphere is a very transparency, and by using a normal microscope, you cannot see the not clear image like this. And by using a 5 measurement ghost imaging, there's a very noisy image. But by using deep learning, here is a very clear image. And for realizing this quality, the normal ghost image has about 4,000 measurement, so 800 times faster. So this is this 5 measurement is has an advantage for detecting some moving sample. So this is one of the experimental result. The glass microbeads, we move this microbeads by using the manually operated stage with micrometer from here to here. So this image is detected normal ghost image with 5 measurement is like this picture. There is no image, but by using the deep learning, so this image changed to this image. So as you can see, the moving particle can be detected with clearly imaging. So also this is many imaging moving direction. As you can see, there is a many clear image. So this is traffic tracking, particle tracking of the almost real-time imaging system, like this picture. So this is a very advantage by using the deep learning. And one of the another case, we applied to the hyper-resolution image. The ghost image, spatial resolution of the ghost imaging depends on this pattern size, 1 pixel size. So that is one of the problem of the ghost image. Maybe there is a projector with this resolution, but to overcome this resolution, it is difficult because DMD is a very large pixel size. So, but in real space, the projected computer-generated pattern is projected like this blurred image by using the projection lens and the objective lens. And so we use this information by using deconvolution, this image, like this picture, near this pattern. And there is many information, borderless information. So by using this information, we can make the many pixels. There is a many pixels. This is a hyper-resolution image. This pixel size is less than 1 micron. So to realize this information, we create this architecture. From here to here, the sample is irradiated these patterns, 4 patterns, and then this is a normal ghost image. So this is a traditional system. And then the convolutional neural network consists of the error compensation part and the sub-pixel layers. And these 2 pixel layers, you can take a very high sub-pixel ghost imaging. Here is a preliminary, I'm sorry, this is a preliminary result. This is a generated pattern, computer-generated pattern. Here is a 8 by 8 pixels by 4 patterns. And then the projected pattern, real projected pattern is here. As you can see, there is a blur of this image. And by using this information, the detected signal image is here. This is a sample here, and this is a sample, and the sample is moving in the 1 pixel on the projected pattern, like this raster scanning moving. And here is a detected ghost image here. As you can see, there are no image. And by using deep learning, the detected area is here because the spatial resolution depends on the pixels. But by using the sub-pixel ghost imaging, deep learning, you can see almost same image from here to here. So by applying this technique for the new imaging system, now there is a 4K or 8K image is generally a television system, but by using this system beyond the 4K, 8K, about 10 mega or 10 giga subpixel imaging. So this is a future plan. So I will conclude my talk. I will introduce the ghost imaging with deep learning, which you can, by using this technique, you can realize to develop a novel imaging application. The ghost imaging is a correlation-based single pixel imaging and combine the deep learning, so you can make a very high-speed image and hyper-resolution image. Thank you very much. This is my laboratory members, but this is a welcome party 2 years ago because there is a pandemic, so we can not hold the party. So the image is 2 years ago. We have this is a member of our laboratory, Professor Takaya, and here is me. And if you want, if you interested in our research area or other Osaka University or the Japanese visiting, please contact my email address here. Terima kasih. Thank you very much for your attention, kind attention.
Thank you very much, Professor Mizutani. A very interesting and very complete presentation regarding high speed and high resolution ghost imaging with deep learning. Professor Mizutani,
yes,
already explained about how one pixel figure can use to have a high speed and high resolution with a ghost technique, and then GI, then continue with convolution neural network, and end it with deep learning. Okay, now we have around 14 minutes to question and answer. Please, for the audience who want to have a question, please just raise your hand in the Zoom. Oh, okay. I think Sierra already has one question, and then another question will be directly asked to Professor Mizutani.
Yes.
The first question is from Novendra Setiawan from Electrical Engineering, University of Muhammadiyah Malang. I want to ask how to make the data set of the ghost imaging using CNN before deep learning. How we get the best quality image that will be the output of data set, because from the ghost imaging you got the random intensity and it become the input. How about the output of data set?
Okay, thank you very much. Very good question. Dataset is one of the main program for making deep learning. This is our dataset for training neural network, simulation-based network dataset. Here is 1 pixel existing. Here is a light existence in 1 pixel, and then the ghost image detected that 10,000 ghost image, and also next pixel also make a data set, and all each pixels there is many data set, but it depends on each pixels. So but there are many data sets, but it is easy to make the data set because simulation based result. So it is easy to make resolution data set. Okay. And next, I'm sorry, other question. What is our other question? I think the data set is one of our question. Okay. And next question, what is the next question?
Okay. Second question, maybe?
Yes.
Okay, please, Mr. Reza.
Oh.
Okay, you want to try for the second question from the first question?
Konnichiwa, sensei.
どうもお久しぶり。
お久しぶりです。
取りまかし。
Yeah, thank you very much, sensei. It's very honored for us to have you in this conference.
Thank you very much. I was looking forward to visit Indonesia.
So, Mr. Tan Sensei, basically my previous supervisor during my master degree. So, I invite him to become a keynote speaker in here since he's a very intelligent and have a very good knowledge in terms of optics and a lot of mechanical engineering things. And maybe, Sensei, I would like to ask only one question. Would you please explain about the application of ghost imaging, maybe in some application? Thank you.
Application, okay. Some application. Yes, yes.
Thank you very much, Mr. Reza.
There are many applications, but one of the advantage I have mentioned, the weak light imaging is the main application. So if the inspection, manufacturing inspection, if it such as defect of the mirror, as you know, the lithographic area, the line and space rule is proceeded to the sub-nanometer resolution by using an X-ray mirror. Okay, but for realizing for fine structures, so mirror quality, you have to make a high quality mirror. But by production the mirror, there is a very small defect in large area. So by detecting the small defect in large area, so the scattered light is very weak. But by using this technique, you can realize to inspection the such a mirror. One of the application of ghost imaging. Okay.
Okay, thank you very much, Prof. Any other question, Mr. Reza? Okay. Okay. For another audience, maybe one more question, please. I think it's a very detailed research, and then we can see here from one pixel, we can develop a very clear result. Anyone? Does anyone? One more question. Mizutani, maybe
Yes.
Maybe Mr. Reza already asked about the application of the ghost imaging in mechanical application, for example, in can this technique replace for example, fatigue test or something using this technique?
Sorry, instead of the plastic?
Fatigue test, for example, for airplane body or something.
Yes, practical test. And we have some project for the XUV lithographic technique.
Yes.
So, and this is yes, I'm sorry, there are no pictures. So this is one of the key point technology. And another one is not the industrial field, the telescopic field.
Yes.
In universe.
Yes.
As you know, compensation system in the telescopic system of the Japanese telescopic system in Hawaii, USA, there is a 30-meter mirrors. 30-meter mirrors. So there are many actuators for compensating the mirror surface. So by using the vibration, so we can see the very weak starlight by starlight information by using this technique. This is a dream application.
Okay, thank you very much. I think so. Very interesting application will be we have in the future with this technique. Okay, I think time's up, and thank you very much, Professor Mizutani,
Thank you very much.
your very interesting and detailed presentation for us this morning. Give an applause for Professor Mizutani. Big applause for him.
Thank you very much.
Baik. Okay, next we will continue with the next speaker, Professor Ilyas Masudin. Let me introduce our third speakers. His name is Professor Ilyas Masudin, MLog, MSc, PhD. His affiliation is Professor of Logistics and Supply Chains at the Department of Industrial Engineering, University of Muhammadiyah Malang. Ilyas Masudin Ilyas Masudin is a Professor of Logistics and Supply Chains at the Department of Industrial Engineering, University of Muhammadiyah Malang. He is also Deputy Head of Engineering Faculty. Professor Masudin, a former Australian government scholar, has finished his PhD program at MIT University. He received master's program at Curtin University of Technology, Australia, and then his bachelor program at the University of Muhammadiyah Malang. Prior to joining University of Muhammadiyah Malang as a lecturer, he is not stated when he started here. Professor Masudin is an expert in the field of logistics and supply chain and operation management. He is now working with some logistic projects such as halal logistic and relief logistic operation. His specialization actually field of logistic and supply chain operation management. Prof. Ilyas Masudin will have around 30 to 45 minutes for presentation, and then we follow with a question and answer. I think it will be quite difficult maybe for us, but I think since the conference is quite wide areas, cover quite wide areas of engineering and technology. I think it can give us another knowledge compared to our basic discipline. Now, time is yours, Prof. Ilyas.
Thank you, Pak Zul. Thank you for your time. So, Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah. Let me introduce myself. Even Pak Zul have introduced my profile. So my name is Ilyas Masudin. So everyone that have question during the presentation can raise the hand and ask for the question or anything. Yeah. So so ladies and gentlemen, again, thank you for your staying. Thank you for your listening in this online conference forum. So for the last session, for the third session here, so we will try to present or discuss a bit different topic from previous speakers that already discussed technically, yeah, about the electrical, about the optics, something like the imaging. So we are discussing a different topic for the last session based on my interest of the research about logistic and supply chain management, considering the current situation about the COVID-19 pandemic. So today's outline, so today we are discussing about the introduction of food cold chain. So the topic would be food cold chain here. And then we are discussing about food cold chain businesses, and also the most interesting about the current situation, COVID-19 pandemic affected the food cold chain. We are discussing about the demand, supply issues, and then safety issues in food cold chain product, and also about the transportation issue, the movement from the point to other point of the supply chain. Also, we are talking about the food cold chain mitigation, specifically in traceability technology. We are not discussing technically, but we are discussing about the performance of the supply chain regarding the food cold chain product, considering the traceability technologies such as ITI and RFID and also blockchain. And also in the last presentation, in the final one, we are discussing about 3 cases study that considering or related with my current research about traceability implication on food cold chain performance, also the implication on humanitarian logistics, and the last one about the model optimization of production distribution considering traceability. So I hope that our discussion, our presentation here, not very too long, yeah, not too long, because this is the last session, so we can go further about the discussion and also questioning. Okay, let's start with the first slide. Okay, so the food cold chain topic is becoming more interesting recently due to the condition of the COVID-19 pandemic. So the title of the presentation today would be Food Cold Chain in Indonesia. Yeah, food cold chain in Indonesia during the COVID-19 pandemic is about the current situation and also the mitigation. Why the food cold chain businesses during the pandemic, during the COVID-19 pandemic is getting more interesting because of 2 reasons. So the first reason is the safety reason. The safety issues is about the risk of transmission of virus along the chain. So as we know that the food cold chain regarding the chain network, it means that there is the movement between point to point, from point of origin to point of consumption. Then it will risk, yeah, it has high risk of transmission of virus along the chain. And also the second reasons why food cold chain is getting more interesting for researchers, for practitioners, is about the supply demand situation during the COVID-19 pandemic. So as you know that the COVID-19 pandemic is getting worse today and affect all the peoples. Yeah, people doesn't want to spend much money on everything that they spent previously. So it will affect on the supply and demand situation in the food cold chain businesses in Indonesia. Okay, this is the network. This is the chain that we are discussing in these presentations. Firstly, we need to define the cold chain, the food cold chain definition. So what is the food cold chain definition? It's a term applied to food handling and distribution where the product is maintained in suitable temperature conditions all the way from harvesting through the cooling, freezing processes to the point of origin to the point of consumption. So from the definition, we can summarize in underline 2 points that food cold chain require facility for inventory, for storing in different condition. So low temperature condition are required for food cold chain. And also the other issue, underlying issue, is food loss or food waste. As we know that during the pandemic, we need to save the food. So based on the research that has been done by researchers in about food cold chain, so the most loss of food is happening on the beginning, in the beginning of the chain. Farmer, supplier, harvesting. Because what? Because there are no facility, suitable facility can be provided by farmer, especially in Indonesia. So it's around 40 or 45% of food will be lost as waste. As you know that the food, especially for food cold chain product, cannot be stored for a long time. The life cycle of a product is very short. So once the food cannot be consumed by market, consumed by consumers, it means that the food will be lost. They cannot be recycled, they cannot be reworked, they cannot be returned. So the food will go to rubbish or final disposal. So this is the big issues that are related with the pandemic, COVID-19. I hope that this presentation can inspire you to your future research considering these issues. So when we are talking about cold chain businesses, it means that we are talking about the other businesses actually. So these businesses, these industry sectors, for example, for food processing industry, fishing industry, meat industry, retail network, pharmaceutical industry, are the supporter of the food cold chain businesses. Most industry here in the figure are related with cold chain businesses. How come? For example, pharmaceutical industry, how drugs, medicine, and also the cosmetic products actually have the same treatment of the cold chain businesses. They need the temperature, they need a special storage for their product. And don't forget that every industry sector consists of supplier, manufacturer, distributor, warehousing, and also the retailer. So we are talking about the big business here. When we are talking about food cold chain product, it means that we are talking about the big business of industry for the other sectors. Why food cold chain contribute to Indonesian economic development? So based on the statistic organization data, the contribution of food cold chain product, food cold chain businesses is more than 10% to GDP, gross domestic product. For example, livestock sector contribute more than 5% of GDP. Fishery sector also contribute a lot to the GDP, and the other sector have also contribute to national gross domestic product. It means that it's very worth it. It's very, very significant when we are talking about food cold chain businesses to the national development economy. So when we are talking about food cold chain product, we are talking about the commodities. We are talking about the classification of the food cold chain commodities. When we are going to the supermarket, especially for the big one, such as Giant, Super Indo, Hypermart, also even in a small store like Indomart, like Alfamart, we always see that there is a special space provided to the customer in the store to install the Giant, the big freezer, the freezer, and also all the product with the hundred of brands stored in the market with the special requirement like this. So based on the classification of the food cold chain product, there are 5 classifications based on the supply. So 5 sources of food cold chain. And when we are talking about the supply of food cold chain product, it means that we are talking about a derivative product, or in Indonesia, we can call produk turunan. So when we are talking about the grains and padi, for example, it means that we are talking about the product contains made by grains and padi like bakery, cereal, pasta, and etc. Hundreds of brands that have to be stored with the special requirement. How about water-based, like beverage, natural water, flavor water, alcohol, something like medicine, something like that. So they should be treated with the special treatment with the low temperature. Also dairy, for example, milk, cheese, and also animal protein, fruit and vegetables. So it's very loud, and the derivative product also. Okay, we are talking about the performance. When we are talking about the food cold chain, it means that we need to talk about the performance of the chain. So when measuring the performance of the supply chain, usually we just using something like efficiency, responsiveness are the indicator of measurement, quality, safety, and service level. But in pandemic, in the COVID-19 pandemic situation, there is one more indicator that we need to consider in our research, in our managerial implication, something like practical. So the traceability is the new indicator that could be the most the most indicator that the most indicator will be in the focus of research for the next research. Traceability. Why traceability is important for the performance? Because traceability can trace in the situation of COVID-19 pandemic. Traceability system can trace the information that contain with the indication or contamination of the virus along the supply chain. So traceability is very important for the COVID-19 pandemic and also in halal logistic actually. When we are discussing about halal logistic, we are not discussing about halal logistic in these sessions, So when we are talking about halal logistics, so traceability is very important, because in the Muslim country like in Indonesia, traceability, keterlacakan for the halal, or the halalness from the point to point along the supply chain is very important, because when we consume something, food, for example, in the end of the supply chain, we have to know the guarantee, the warranty that the product is halal. One level, one channel, one level of supply chain along the supply chain cannot guarantee the product, the halalness of the product. It means that the product we consume is not halal, is not good. So the traceability in the halal logistics is very important, and it's become more popular now for researchers to include the indicator of traceability in their research, especially in some logistic area like halal logistic, and also in humanitarian logistics, something like that, and also in relief logistic. When we are talking about the humanitarian logistic kebencanaan, it means that logistic kebencanaan or humanitarian logistic not only about logistic in the natural disaster, how to manage logistic, how to moving something from point to point, but also when we are talking about the traceability in humanitarian logistic, we are talking about how to moving something in the condition of natural disaster is a kind of natural disaster, but also social disaster like COVID-19 pandemic is kind of other disaster. So disaster not only caused by the natural disaster, but social disaster like the outbreak of COVID-19 pandemic is one of the cause of the social disaster. So traceability become one indicator, one of the most popular indicator in the future. Okay, COVID-19 in Indonesia, since the spread of COVID-19 in March 2020, so there is side effect of the outbreak, the spread of COVID-19 since March 2020, such as social restrictions, lockdown, and what we call PSBB, something like PKMM, something like level 4, 4 level in the latest lockdown of the government's regulations. So the pandemic has changed the way of treatment dealing with the food cold chain. Absolutely, there is a very, very basic treatment changing. So when we are discussing about food cold chain, supply chain issue in COVID-19 pandemic, we got the data here that 50% of logistic company decline their profit, their benefit, their margin, their revenue. Not only in logistic business actually, but it's effect on the other business. But we are focusing on the logistic and supply chain businesses that 50%, most of them are decline the revenue, decline the sales, decline the profit. And also in macroeconomic growth in 2020, it also declined up to 2.3%. Yeah, far decline comparing with previous economic growth before the pandemic, more than 5%. So decline more than 50%. And also, as the result in Indonesia, the cold chain business and supporting business sector in Indonesia also decline. This is the consequences that 50% decline of logistics sector. Okay, this is what happened in the supply demand issues in food cold chain businesses during the pandemic. So there is overcapacity actually. Based on my research, there is overcapacity because of the demand decline issues. People doesn't want to spend a lot of money now for their spend, for their needs. They will consider more than twice to buy food, something like that. So there is a very massive decline in demand. So what happened when demand is declined? So the supply, it will affect the supply. The supply will be over capacity. We have supply of distribution center. We have also market, retail, and truck that have a supply from the level, but there is no demand in the end of the consumption. So there is overcapacity along the supply chain, from supplier to retailer. So what happened when food cannot be for a long time? Food have a very short life cycle, so the food will be damaged. We return, we cannot recycle, we cannot remanufacture the food again and sell it to the market, but the food will be rubbish and go to the permanent disposal. So this is very interesting to discuss about the supply demand issues of the food cold chain during the COVID-19 pandemic. Issues about the food cold chain safety. So now people very concerned about the safety, everything, including food. Food cold chain product will be one of the product that to be changed based on the safety issue. So when we are transferring to a point to the other point, the issue of safety will arise regarding the COVID-19, regarding the transmission of virus of corona. So the issue about staff training, because our worker, our staff are not well trained previously. With the COVID-19 pandemic, worker need to be have a good behavior in sanitation, in hygiene, something like that. Also about the training periodically. Worker need to be trained because sometimes worker need to be reminded periodically. And also about the shift, working in shift, working from home, something like that. And also about the personal protective equipment. So worker staff need to be equipped with PPE. Also hygiene and sanitation issue need to be considered. So the safety of the food cold chain product need to be concerned by the workers. Other issue about the food cold chain product regarding the COVID-19 pandemic is in transportation issue, distribution issues. Again, sanitation protocol, something like always using hand sanitizer and physical distancing, protecting clothes, something like that, have to be concerned by all the stakeholders along the chains. Also, one more about the packaging. Packaging will be the raising issues in the next future, in the next research, considering how to design the recycle, something like that, recycle packaging that have to be once, when we use packaging in our in the product, in the food cold chain product, should be once only, cannot be reused again. So this is the issue rise between during the COVID-19 pandemic. Okay, we are talking about the traceability. Before talking about traceability, we need to know the key element of quality food supply chain. as you see in the picture, that there are three elements that affecting the supply chain performance. The first one is information flow, financial flow, and also product flow. When we are talking about the supply chain, it means that we are talking about the movement of the product from point of origin, supplier in the left-hand side, to the point of consumption in the right-hand side. So the product will flow from the left-hand side to the right-hand side, to the supplier, to the end of consumption or customers. So and also the financial flow will flow in the reverse, from the right-hand side to the left-hand side. The more product flow from supplier to consumption, the more money come or flows from the other side. So one more element is about the information. Information flows from to both way, from left to right hand side, from right hand side to left hand side. The information about the product sale, the product flow, and also the brand, how many, the quantity, and also who's the supply, something like that. Also information about the money. So the information flow here must be accurate, must be safe. Therefore, information is the driver in the successful supply chain management performance. So this is when we are talking about the information, the accurate and also the valid, the safe information that flow the data. So we are talking about the application that can be installed, that can be used by the stakeholder along the supply chain network. The one is electronic data interchange. This is the most popular used by the stakeholders during along the supply chain. What is IT or electronic data interchange? You can see that electronic data interchange can transmit information from one computer to another regarding business transaction between organizations in the supply chain. What is the benefit? The first one, that the adoption of electronic data interchange in organization is important because it can facilitate the transfer of information quickly and automatically, and so simple. The second one is radio frequency identification, or RFID. So this is the benefit of RFID. And the last one, the latest one that is quite new, is blockchain. Blockchain is a reliable database in the form of a blockchain that contains data or transaction within a certain period. So this is the latest one based on the cryptocurrency issues. Then blockchain is quite tested and valid, and also safe and secure technology that can be used by the stakeholder along the supply chain. The next slide will discuss about some case studies to investigate the impact, the implication of the information system, especially for traceability application, and its implication on the logistic and supply chain performance. So in the next slide, we'll discuss actually to prove that some application in traceability system impact significantly on the food cold chain performance. And also in the second case study later, we are showing that the traceability system like electronic data interchange, radio frequency identification adoption, and also blockchain adoption have a very significant implication on the humanitarian logistic or kebencanaan or relief logistic in the pandemic. So this is actually the statistical data analysis that prove there is a very significant implication about the adoption of traceability technology to food cold chain performance. So this is the result of the research. Yeah, the 3 technology application is tested, and it is also show that blockchain has very high demanding, high implication, the highest implication, then adopt the other technology. Okay, we come to the second case study, our traceability system on Indonesia on relief logistic services. So it shows that the adoption of traceability system, traceability technology, also affect on traceability of humanitarian logistics. So we already know that humanitarian logistics is not only talking about the impact of natural disaster, the logistic on natural disaster, but also the logistic strategy on the social disaster during the COVID-19 pandemic. So it's that the traceability system, the traceability technology adoption impacts significantly on traceability of humanitarian logistics, and finally will affect on humanitarian logistics performance. It's very important. The clues that we can further discuss or investigate about the application of traceability technology adoption on the other aspect of logistics. Okay, this is the result. And the last one is about the case study number 3, is production and distribution model considering traceability and carbon emission. Case study of Indonesian canned fish food products. So canned fish product is included in the food cold chain because there is treatment should be given to the product. The treatment, something like the temperature, something like store in the specific contain, something like that. So this is about how to develop the mathematical model during the longer supply chain management in the fish product. So it is also indicate that the application, the use of traceability system depend on the traceability system will cost different amount of money that will affect on the total production and distribution cost. So with the model, something like in the figure, we can develop a mathematical model to solve the model of minimizing logistic costs, considering the traceability issues here. So I think that's all our presentations today, with the conclusion that in the COVID-19 pandemic, so we need to modify the strategy of our businesses, especially in food cold chain businesses. So one of the strategies should be we have to adopt the traceability technology. Yeah, so traceability technology adoption would be one option that can be done to mitigate the COVID-19 pandemic, to survive the business, and to minimize the cost, to minimize the food loss, to minimize the waste, food waste, or something like that. Okay, that's enough, Pak Zul. Thank you.
Thank you very much, Prof. Ilyas, for the presentation. Very nice issue already explained regarding food chain in Indonesia during the COVID-19 pandemic. I think it's a very hot issue that we face during almost 1.5 years. Now we have to, we will continue with the question and answer. We have 2 questions here. I will read both questions, and then maybe we continue for another question from Zoom. We have 2 from chat. From Mrs. Amelia from Civil Engineering. I want to ask about how was the effectiveness of food cold chain that can make Indonesian farmers change their way to storage production. It's related to behavior of our farmer. And the second one is from Mr. Adi Nugraha. How ready is Indonesia in applying the food cold chain system, especially in Indonesian outside Java and Sumatra? This might still be uneven in supporting technology for the food cold chain, such as electricity and packaging. That's all 2 questions. Maybe another question will be asked after answer from Prof. Ilyas. Maybe you mute.
Okay. Yeah.
Okay, Prof.
Sorry. Yeah, the first question asking about the effectiveness. Yeah, in the beginning process along the supply chain. It means that we are talking about the farmer, the harvesting process, and also the supplier. So how to make the effectiveness of, I mean, relating with technology in COVID-19 pandemic situation. So this is our concern actually, how to manage effectively to solve the problem that farmers, suppliers, harvesting process can effectively do their process, yeah, even in COVID-19 pandemic. So the solution can be offered is about technology, I think. Yeah, the IoT and also the technology of what's it, online system, something like you can buy online. So technology should be applied, yeah, since in the beginning, since farmers, since in the level of beginning processes. So technology that can make the process is shorter. When we are talking about the movement of product from the beginning to the point of consumptions, it means that we are talking about the long journey of product transfers. So let's make shorter. So farmer can also to be storage people. So farmer also can be a salesperson. Farmer can also be harvesting people. So farmers need to be equipped with technology. So make the shorter supply chains. The network should be shorter, like what can do the business. Cut some of the network, no more distributor, no more retailer. So they will sell directly to the customer. So this is what we can do, what we can offer to government, that government should take the responsibility to provide the technology, even in the beginning process to the farmers. So farmer can sell directly to the customers. In the pandemic, we don't have any choices. So provide with the technology, even for the beginning processes, even for farmers, so they can sell directly to the customer. So this is the effectiveness of the technology that we can offer to the situation. Make shorter, long supply chain, make it shorter, so we can sell, farmer can sell directly to the customers. So this is the issue that we need to rise. Yeah, we need to rise to the government, to the researcher, to the practitioners, that technology should be provided. Thank you. So again, for the second question. Yeah, okay, Pak?
Yeah, continue for the second question, Prof.
Okay, yeah, make it short answer about the second question. How ready is Indonesia in applying the full cold chain system, especially in Indonesia, outside Java and Sumatra? Okay, yeah. This is the issue about the regulation, the government involvement. Yeah, the government has the responsibility to provide jaringan or network in all Indonesian parts with the same quality, I think. So yeah, as a researcher, we have to push the government to spend more money, yeah, to upgrade the technology outside the Java Islands. Yeah, I think that's all, Pak.
Thank you, Prof. Ilyas, for the question, for the answer. We need one more question from the audience. Maybe a direct question, not using a chat Zoom. Does anyone? Okay. I think no more question. I think it's enough. Okay, thank you very much, Prof. Ilyas. Let's give a big applause for Prof. Ilyas for very nice presentation this morning. Okay.
Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Prof. Ilyas. That's all for today. I think our speaker already delivered his presentation, and then today we receive three very nice presentation, or very nice speech from our presenter, our speaker today, and then hopefully it will give us very new, will give us a new knowledge about three areas of we have the areas of presentation from the speakers. Okay, that's all. I think thank you very much for Prof. Taufik, Prof. Mizutani, and Prof. Ilyas for our first section today, for plenary session today. On behalf of committee of the conference and University of Muhammadiyah Malang, we say very thank you very much for your presentation in this conference today, and hopefully the next time we can meet again in another event. Hopefully it's not in virtual conference, hopefully in a real conference, and you can come to Malang and join us together for discuss about several topics, and then I think it will be very interesting. For the audience, thank you very much. That's all for our session today. And then I'm as moderator say thank you for all of you for your participation in this discussion. And see you again. And I will continue with the Master of Ceremony for closing. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for our moderator, Mr. Zul Fatman, MA, PhD. Also the speakers for the knowledge, information, and insight for in this conference. Okay, before leaving this room, to all audience and participate, please open the camera to take a virtual picture together. We will take a picture, so you can open your camera first. Okay, I will take a virtual picture from here. Okay, 3, 2, 1. Okay, once again. 3, 2, 1. Cheese. Okay, and the last you can free pose. Maybe you can raise your hand or you can say bye bye. Okay, are you ready? 3, 2, 1, and cheese. Okay, thank you. Thank you for all the participants and all audience. Also the moderator and the speakers give more information and knowledge to us. Okay, we will see you again at 12:30 p.m. to join this room for parallel session. So you can take a rest. Then you join this room again at 12:30 p.m. Once again, thank you and see you again at 12:30 p.m. to join this room for the parallel session. See you and bye-bye.